Welcome to Ask the FM Doctor, an interactive web series brought to you by the Simplard Foundation and IFMA to help you navigate the complex and ever-changing world of facility management. Whether you're a seasoned professional or a newcomer to the field, you'll find valuable insights and tips to deliver a better experience for your stakeholders while saving money. Join us on the third Tuesday of every month at 1 p.m. Eastern U.S. time to learn from our FM docs while connecting with other facility managers from around the world. Register today at simplerfoundation.org/FM-doctor so you don't miss an upcoming session.
Okay, well, thank you all so much, and I hope everybody's doing well today. Thank you for being here. We are absolutely thrilled to have Brian Stone with us. Brian, I think we've known each other for more than a decade. I think it's more like 20 years, but we've known each other a long time. He is our resident drone FM roof inspector guru, and we're so thrilled to have him here. And with that said, Brian, the floor is yours. Thanks for being here.
Yep. Once again, thank you again for letting me have the chance to share some of the work I've worked with. Dealing with drones, it's something I got into really as a professor. I got into it because it was fun, but I dove into the research side and really trying to help find ways to help industry make use of this technology using drones, unmanned aerial vehicles. So my experience, a little bit about myself. I'm a professor at Brigham Young University, Hawaii. I've just moved here this past summer, and but spent a lot of my career in Illinois, Western Illinois, which I'll show you a lot of pictures here of some of the things that we've done and how we did these things. So my credentials: I am a licensed FAA 107 carrier. I have over 300 hours of drone flying experience. I consider myself an advanced novice. I'm not, I don't race drones or anything like that, fancy stuff, but used several of the software out there in industry. I won't go through that today, but just I am experienced in that. About 5 years using drones. I'm also an OSHA outreach trainer for 10 and 30-hour cards. So the safety part of things is a part of how I understand how this works. So some of the ways that drones are used, also known as UAVs, unmanned aerial vehicles. You find these used in geography, agriculture, farming, construction project management, surveying, real estate, search and rescue, emergency response. And my push here is to encourage and demonstrate how it can be used in facilities. Some of the common questions, if you haven't gotten into drones, using it for your workplace, the questions that may come up are things like, should I be using UAVs for my facilities? Should I contract it out, or get someone in my workplace to be the drone person? What's the cost basically to our company, time and materials? And then the range of drones. Should we get, what kind of drone should we get? $10,000, $20,000 drone, cheap $50 one? What are the legal requirements, and will it actually save us money? So those are some of the things I'm going to cover in part today. There are 3 parts to that I would say are important for drone use in industry. One is you probably need to be licensed if you're going to do anything commercial for pay. The 107 license is a requirement. Get some piloting experience, and also learning the software. So I'm going to cover the first 2 on this slide here. Software gets a lot of other things involved. So I'm going to start this with the question: what is the most dangerous tool at the workplace, whether you're facilities or in construction? What is the most dangerous tool out there? And I will show in the next slide what it is. Think about what you think it is. The most dangerous tool in facilities and construction is this. It is a ladder. Anytime you have somebody that has to go up a ladder and up and down a ladder on a roof, to look at something, look at a site, that's cause for problems. There's actually a push with OSHA to see if they could do away with most ladder use because so many problems with the falls that happen. So I put together this slide. That guy on the left is he's my AI inspector, facilities person. And just a side joke, I uploaded him a picture of myself, and I said, draw a picture that looks like me, and as a building inspector. That is not how I look, by the way. I don't look that good, but all right. So safety, from a safety perspective, This is from the Department of Labor. 30% of construction fatalities come from falls. And when you fall from a roof, it is very likely it's going to be fatal. Anything above 11 feet, and there's a good chance you could die from that. Just adding up the cost for a fall, you break a leg, you're looking up to $60,000. We did some of the research on that. $60,000 for recovery, rehab, loss of work. And that's from one fall. So if nothing else, drone use is helpful to avoid in falls. Other things that are safety concerns is weather, fatigue, distractions while you're climbing up and down, traversing a roof. So let's see. Some things I wanted to point out. So obviously safety is an issue. Put down the numbers there for that. Another thing is time savings when you use drones. We did some research there on that. What's the time savings versus going up yourself or sending someone up there? You can document buildings better, your structures or your property. You can do it by date, by GPS tracking. Also, you can do a maintenance planning with this. So I'm going to go through that. Some of those points. Let me just talk through getting started. I'm assuming that maybe you've never worked with this before, and I know several of you may have, but never worked before. And I'm just going to walk you through some basics and then show you a bunch of different examples of how we've shown that it can be used. Now, before I move further, I'm looking at the chat line. Let's see, checking here. Jake, I'm going to let you look through that. If there's any questions that need to come up, feel free.
Yep, I'll keep an eye on it. Yep.
Okay, great. So getting started though, price range for drones, you can go simple, mid-level, or high-end. What we recommend is about this range for most drone use in industry. I would say stick closer to the $1,500 range. They've got great cameras, decent battery life. You can go higher end, these $800 to $40,000 drones. But if you're looking at expenses and you want something quality, you can get something decent for $1,500. The FAA license, it is work. It takes some time. I put together a list of things that are on the typical test for it. It's about $170, almost $200 to take the test. And it's like a lot of other tests. They'll let you test 2 or 3 times off of the fee, but you do need to study. I put together I tracked my own study research. 12 hours is what it took me. And basically I watched a bunch of YouTube videos over and over, people that walk you through the test questions. Anything from, the age to fly drones, learning about what NOTAMs are, stall speed, METARs, a lot of information. Alcohol and drones don't mix, things like that. A lot of information that may not be what you use day to day, but they do deal a lot with safety there. So that's just a quick list of the questions there. And I'm sharing these slides with Jake so you can share those with people in the future. If you get the license though, what does it do? It lets you fly commercially, charge money for it, or at the workplace. You understand the laws of safety, regulations, which is great. What it does not do, it does not make you a good pilot. Getting your license does not make, it's not like a driver's license where you have to prove yourself in driving a car. It just gives you a piece of paper. It does not teach you about industry software, things like that. So let's move on. Now, if you're going to fly drones, you think you're going to jump into it. The key is practice, practice, practice. I'm going to go through some examples of how I practice. This was my setup. About $1,500 got me a basic drone. This is DJI Mavic Pro, a little iPad mini, and then the controller. Also, I bought some containers to safely hold these things so they don't break. And I put them all in a backpack, and I went out and started practicing. 5 batteries. These are a list of places I went when you go hiking. I went to my son's football camp, took it with me, filmed. I filmed a parade, parks, went to parks, my kids playing, gathering events, I did a wedding. Here's an example of some pictures that I took when I was first learning. On the left is a wedding that was going on, a friend of mine and our neighbor actually. And I says, hey, can I fly the drone around and take pictures? And did that. Family picture in the middle. You can see I'm doing a great job at taking the picture. I just forgot to look up for the picture. And so bottom right is me teaching some high school students about how to fly the drone. The student is flying it, and that is our grad student in the back. He looks a little worried, Omar, with the purple shirt on. So he's hoping he doesn't crash it. Anyway, practice. This was our local water tower in the Midwest, Illinois. Got up, checked around. I got close enough that I could check the welds on the tower. This obviously had a cell tower on it. And I was probably across the street, maybe, I don't know, 300 feet away. Sorry, 300 yards away, 300 yards away. But on these pictures I'm going to show you, I want you to consider what would it take in terms of equipment, safety, time, and cost to get these pictures without a drone. If you were to get up to the helicopter, ladders, what would it take to get up there? Here's an example of a windmill local in our area. You see how close I could get with it, checking the fins. I know the inspector of these windmills here. I talked to him. He literally, I thought there were elevators in these things. He literally had to climb up each of these to check each one. And so you can imagine the work involved, at least from the interior. But I was able to take this up in a few minutes, 350 yards away, and take it up and then bring it back to take pictures of the again, equipment, safety, time, cost. What does it take to get these inspected? And by the way, talking to that guy doing the inspections, he said that partway up some of these, his leg would start to cramp up, and then you get into trouble climbing that ladder. Here's another example on campus, checking the stadium lights. In this case, I was just looking for nests, hornets nests, things like that. 400 feet away, 80 feet up, checking that. So again, how do you get these pictures or this inspection done without compromising safety? One of the things I learned as I started moving along with drones is there are 4 main settings on any drone that you need to make sure you can learn how to do, and that is focus, white balance, ISO, and shutter speed. And really what you're just trying to do is make the pictures look easy to see, so that when somebody puts it on their computer, they can see it well, clear. I came to Hawaii about 6 months ago, did a great drone inspection of the town I was in, took it back to Illinois, and opened everything up, and it was all blurry. So focus, make sure, get your focus thing. White balance, ISO, and shutter speeds. You can Google these, look them up, great trainings on them. They're just settings on your drone that you need to learn how to use and do. Residential is an example of, actually it was my house in Illinois, showing a close-up and a faraway picture. Again, what would it take to get these things, get these pictures inspected without the use of this technology? Some of our buildings on campus, drones. The key thing here we learned was you need to take any penetration, anything poking out, a parapet wall or vents. You need to get various angles of them to be able to show, okay, what's the condition of them? Are there leaks? Are there cracks? This was another client we worked with. They had a lot of historic buildings. You can see that these cedar shake roofs, checking for leaks, checking for damage or wear on them. And this group, they had over 100 buildings like this. So what would it take to do that? A football stadium, concession stands. You see they're doing some roof work there, getting some close-up pictures of it, seeing, their temporary patch on the roof. What would it take to get these? So we developed several protocol steps. When you do any building, you make sure you get an overhead view, take a short video flying around it, and then get angular views, take an angle picture of all of the penetrations, get as close as you can. Sometimes the client will say, hey, can you take a picture of this part? We have this one part of our roof got torn off, get some close-ups of that. We've got hornets here. So a lot of things that you do over and over. These are the steps we did with some research presentations on this. And then that step number 7, formatting. That is a big part of getting this all organized, keeping it organized so that you can view it later. That's done at your desk. So these are a couple more pictures. There's an AC unit on top of a roof, getting it's part of a roof inspection. So a few more pictures I'll show. This one just shows how close you can get. Take the picture from 40 feet away, but when you put it on your desktop, you can get it as close enough so that you can see, is there any issues with the mortar, the grout, the flashing on the roof, what do you call it? The cedar shakes. So if you check in quality there, really nice opportunity to see these up close. Each building, by the way, took us with setup and takedown about 10 to 15 minutes. So pretty quick. In one day, I could get 20 plus of these structures inspected following that protocol I talked about. Here's another example, our library. You can see one section, they looks like they did some work there and then forgot to rake back the rocks, which should have been covered back up. Another example of another structure we had, that a lot of leaks in the roof, side of the building. Whenever it rained and the rain went sideways, it came right through the windows and leaked all over the floor in the classrooms. So this ended up triggering or helping to demonstrate the need for a caulking job. They put the caulking on all the windows, seal up that issue. This is another example. Student housing, I'm using a lot of examples from our university. I had a pretty good relationship with our facilities person there. They had an issue with the student housing, the dorms, where about every spring, middle of spring, and then the middle of fall, they have these bats and hornets that would just come out on the buildings. This is about a 15-story building. And so rather than doing some high-end, angle pictures, all I did, hopefully you can see this all right, I flew the drone looking for holes or gaps in the roof. So took the drone, fly up, stop, fly up, stop. What we found, it was hard to see from the ground, but let me pause right here. This is about the third or fourth floor up. Between the windows and the brick, we found that there was a gap, that the seal had broken or, come separated. And so all along, third, fourth, fifth floor up, you have this gap that was coming through, and the bats and hornets, they'd go in there and just, make their home in there, which caused all kinds of problems for the students. So that was an example of, helping to solve a problem. Let me get back up to here. And right there. Okay. Helping to solve a problem of what's going on. How are these hornets and bats getting in? Again, how would you get these pictures taken without some technology like this? Here's another example of a large building. In this case, it was a chapel. They're looking to re-roof, and they have to decide, is it time to re-roof or can we wait? You can see, obviously, with the drone pictures, this particular research was done by Dr. Bowen, one of the initiators on this work that I followed. You can see areas of the roof that are damaged, but they're not sure if it's time to re-roof. They get the drone out, take pictures of different sections of the roof. Then they get up right close. They can see that there are some damaged shingles. Detail view, really close. This shows how close of a picture you can get, at least when you zoom it up with the drone. And what they decided was most of the roof is in good shape. Just these spots are causing problems. Here's their analysis of how well you can get from how well a quality of pictures you can get 15, 10, 5 feet away. But the point with all of this is they decided that, we don't have to re-roof yet. We can just spot patch and put this on a maintenance schedule for 2-3 years away, because the roof is still in good shape, which saved quite a bit of money in terms of not having to do that work yet. Without the drone use, they would probably just walk it and sort of stumble across the top and then just say, yeah, let's just re-roof it. My legs are sore from walking around here. So that was an example, again, money saved. A couple more things I wanted to cover. One is, how do we organize all of these pictures? We did a project where I was able to document all of the roofs at our university in Illinois. This is Western Illinois University. I used Google My Maps, which is a free software package online. And you can see what we did is we put pins on the map for different parts. This is one of our campuses next to the Mississippi River. Pins on each of the buildings, and then each structure in the description of it. We were able to, there's a close-up view of it. We were able to put a link there, and in that link, it would take us straight to Google Docs. If you've used that before, basically it's a set of folders and an online space that you can put things. I put all the pictures there. This is that building that was shown on that their other view there. And so we documented over 100 structures here, total, and did the standard protocol, top view, angle views of everything. And you can see how close you can get of, for instance, in this case, a hatch door that was on one of the structures. So this just we handed the information over to the facilities person. They now have a documented version of their roofs for that year. So just to give you an idea of how many, this is our other campus. This is all of the buildings that we documented. Each one has a link. Each one has the pictures that follow the protocol. And they could just click on it and say, okay, these are from this particular year. I think it was 2020 when we did this one here. Right during COVID, actually, which was that it was a great time to fly a drone outdoors and things. Each building link, and then the pictures are all in there too. So this was a great work. I used this for my sabbatical. So that was my my semester there. Again, I just show this one. It was right above my office. And let me tell you, my office leaked water. So I could show them up close. Hey, it looks like you're leaking right there. They did re-roof about a year or two later. So that was nice. Okay, I want to end on thermal imaging. This is what we got in towards the end. It's a different drone. Your standard drone that we use, DJI Mavic Pro, was about $1,500 range. But this higher end one is called the DJI Mavic Enterprise. There are a couple of different other versions of it. And then what it does is it takes two different pictures. One is a normal picture, and then one is a thermal image. And this video on the left, I'm not going to show the video, but just so you see the picture here, they'll take a surface below, for instance, like an OSB plywood piece. They will draw the word wet on it, just in water. Then they cover it with your standard black rubber roof material. And then they shine light on it, let it heat up, and you take the light off. And what you find is the water underneath the roof it slows and it heats and cools at a different rate. So you can see it if you put a thermal camera on it. So with that, I'm going to jump over to the next slide. This is an example of what we did with our thermal camera over at a daycare center. You can see on the left there, it was in the fall. The sun was setting, so the roof was heated up, but it was cooling. And on the surface, it looks dry. You can't tell any leaks, but you look on the right side picture, that's the same picture with a thermal image on it. It shows how much of that water, that moisture is underneath the rubber top. In this case, this was a pretty solid example of showing, hey, you've got water damage underneath your rubber roof. It didn't mean that it was leaking yet, but it did show that this is an area that is deteriorating there. And we did that for about a couple dozen of the buildings on campus, and we got to show them these are buildings that you may want to look at for your maintenance schedule. Another example, on campus, they had a steam line leak. They were losing material. This is what they used for heating the campus buildings all over. So the underground steam lines all over the place. Left side is a picture. This was an early morning shot. And what I'm looking for is any steam or heat signatures showing where the steam lines are. They did not know where the leak was. And so my job was to just take pictures and video of the area to show them, okay, these look like hot spots. In this case, you can see that sidewalk there is a hot spot. Doesn't necessarily mean there's an issue or problem there, but it shows them that, hey, this is an area you may want to look at, right, in that sidewalk area. Steam lines were probably 4 feet underground. So you could see, where these signatures show up. And I flew across and showed several hot spots on campus. One other one, residential one that we did this summer, the housing group asked us to see if we could find leaks. They had an irrigation water line running through here, and it seemed like they were losing a lot of water. They felt like there was a leak underground with their irrigation water lines. So we went through early morning one time and took these pictures. Left side is the homes. The right side is the heat signature scans. And in this case, we were looking for cold areas, dark pictures. We did not necessarily solve the problem for them, but we did show them, this is the data that we're finding, and you can make an assessment from that. And see where you might want to check around if there are leaks or, mucky, muddy ground areas. Okay, so let me wrap up here with just the summary on the data with our research. In the case with the pitched roofs with the cedar shakes, that particular customer, he was working on a master's degree in facilities management, and we inspected almost 500,000 square feet of his property roofs. What we found was each building took about 15 minutes to do setup, takedown, and then actually doing the inspection. But it took another 30 minutes of compiling the pictures, organizing them, uploading them to Google Docs, and handing over the information. So that just gave us, we came up with the number 47 minutes to digitally document a building. That's everything from start to finish. We also, this is just some of the sub data that went with that. We also found that he saved 40% of time doing the inspections with a drone once somebody was trained. So that was a big deal here. And then there's a safety issue. So time and safety, big selling point. Backing up your data, it's important to make 2 or 3 copies of it. We used thumb drives, jump drive, the external drives, and then your actual computer. And then we'd upload it to in this case, Google Drive. All the way through. That was, again, part of the process. And at that point, the owner would have a copy of all of that year's roof inspection information. Okay, so some last things. I mean, $10 for a thumb drive gave you all of your roof inspections. It's very inexpensive. And then just setting up the drone itself, $1,500. And then I think another slide I did not put in here, it was another $1,000, $1,500 in time for an employee to do the studying, take the test, things like that. So very inexpensive overall. Here's a comparison of if you were to do it in-house or contract it out to somebody else. The savings there, basically a month to do these 224 structures, as compared to if you outsource it, it might cost you $18,000, $22,000 there. So it just giving a facilities manager a set of numbers that show, yes, this looks like it could work. You just need to invest in getting someone trained, or at least getting a good contractor to do the work for you. So hopefully this gives you some ideas, some thoughts, some questions on what is done, what can be done. And I'm here to answer questions and share the information we have. It's a lot of fun for me. This is the last picture is one I took of our campus. And as you can see, there's a lot of those coconut trees in the way, but it's really neat opportunity to work out here. Okay.
That's an awesome picture, Brian. Thank you. Well, thanks. I mean, that's super insightful. We have a couple questions, Brian, in the chat box. Our first one here from Colin is who are your main customers and where do you find them? So, Brian, I know that you probably do some consulting and other things that you have in the past for this type of work. Can you talk to us a little bit of how you kind of approach that? And then other folks, if you do have questions, be sure to put in the chat box and we'll get to it. Go ahead, Brian.
Sure. So there are different views on it. For instance, when I was first getting started, it was more like we would work together with our facilities manager. I just said, hey, I've got this project I want to work on. Can we use your structures as kind of like a guinea pig? Can we do the inspections here? And we'd gotten to where we had a good relationship. So he said, yeah, sure. So we had a protocol. We'd call up the security office, say, hey, we're going to be flying around here. That was initially who we worked with. We had another local facilities manager that over about an hour away that had about 150 structures. And in that case, we were friends, and he was working on his master's degree in facilities management. So really, for me as a professor, it was a chance to do something fun, something I enjoy, but also document it. And then some of the others with the, the residential community, that was somebody that we'd worked with. For me, it was always good to document it so I could use it for research. There are a couple of companies out there that do drone inspections. They basically run the framework, the finding customers. I can't remember the name. They just changed their name, ZiteView, and then there are a couple others. But you basically register with them as a drone pilot. You do a few of their trainings, specific trainings, And then they send you jobs. They say, hey, there's one here for $50, $100, $150. You want to go do it? And then you say yes or no. And then you schedule to go do the trip, do the project. You know, they work that. I've worked with that for a year and a half. It's pretty nice. And then if you go on your own, if you don't want to use another third-party company, you can work with real estate agents. In Hawaii, there's a lot of real estate type of projects going on,
Sure.
things like that. So
Awesome. Colin, go ahead with your follow-up.
Yeah, thanks. Appreciate it. This might be a little bit of a special case or random question, but just thought I'd ask it anyways. I'm working with a company that does light poles for like parking lots and stuff. And they recently, actually a couple days ago, had me go out and they want to measure the diameter of the top of the light pole that's 90 feet up in the air so they know what size brackets they need to put the new light fixtures on. And the best solution that I've come up with is to put like prop guards on my drone and then more or less attach like a ruler to the drone, fly it up, touch the top of the pole, take a picture, and then bring that data back down and get those measurements for them that way. It worked, but it wasn't the best. I crashed a couple drones on that project, and just wondering if you knew of any drones that had LiDAR technology or maybe some sort of software that would process something like that.
yeah, well, that's a good question because if you get into LiDAR, they're still pretty pricey. I mean, you're talking 10, 50,000. And then most drone scanning that I know of is for what do you call it? Surveying. So they'll do GPS tracking spots. They'll scan. You can get volume checks on how big of a hill or a mound is of soil, dirt, things like that. But for a small, you're talking like a bolt head or just a small little bracket.
Yeah.
That is, I mean, I think you're on the right trail with getting a ruler on there. But anytime you attach things to the drone, and you know this, but anytime you attach things, it makes your drone, I guess you could call it bottom heavy. You know, there's top heavy, but if you start to sway like that, and I've done that before, where you're trying to carry something or see what you can pull off.
Yeah, I first started using like a DJI Mavic Pro, and
Yeah.
I had like a couple like really thin sticks that were holding like a ruler that maybe stuck out 8 inches, and it was a little wobbly, but it flew fine. The only problem was it ended up catching on the hardware up there, and it flipped and crashed.
Yes.
So I actually brought out the DJI FPV drone,
Yep.
and surprisingly, that one was a little bit more stable, and it's got like the auto recover, auto hover safety feature. So that's been working pretty well. But yeah, thank you. Just thought I would ask to see if you had any better solutions.
Yeah, I don't. I think you're on the right path, but and they're trying to move in that direction with what can a drone do? Can you pressure wash up side of a building with it, and how much you can carry? But you're talking almost like surgical movements with it.
Pretty much, yeah.
But yeah, I don't have any other contributions. It's a great question.
Cool. Thanks, Brian.
Yeah, thanks, Colin. And that kind of follows up, Brian, with that Kendall's question about LiDAR and photogrammetry and LiDAR use cases. Can you tell us a little bit more about that? What you've kind of seen with LiDAR, Brian?
So yeah, LiDAR basically it's a scanning software that you can a technology that you can fly over an area and it will go right through the trees. Basically, it'll find the ground level. So no matter how much jungle bush that you have in the way, it will just tell you where the ground is. And I can't remember if it can work underwater or not. But the main thing with LiDAR is it's getting less and less expensive. So you're seeing more and more of that kind of technology used. And this is probably 4 years ago, 5 years ago. They just ran LiDAR over whole sections of land in South America. And this is a facilities issue because they found over 60,000 structures that were built there, but you can't see it because it's in the jungle. So my joke is, yeah, see, they had facilities managers back then with 60,000 structures to take care of these buildings. But yeah, it is getting cheaper. It's just a matter of time before it becomes useful for us. So yeah, it's great, but it's out of my price range. My price range is around 1,500. Well, I will say when we use the thermal camera, we co-opted with the facilities manager. I first told them I'll do this all for a certain price, and then that would have paid for the drone for $4,500, $5,000. They said they couldn't do it that way, so I said, well, what if you guys buy the drone? Let me carry the case, the drone, but it's yours. So basically, I had the rights to use the drone any way I wanted, but it was owned by them, and they were pretty happy with that because they didn't know how to use it anyway. And I was anything they needed, I'd provide them pictures and things like that.
Yeah, that's awesome. I have a colleague. She has a robot dog, a quadruped, and it has a LiDAR. Kind of looking to attach it, and the dog will like go into collapsed buildings, capture 3D scan of what's actually going on.
Yeah.
That's what I've seen too, Brian, is that the cost for that is super high, and I don't think the price points are there yet, depending on what folks are wanting to do.
Yeah. For a facilities manager, a lot of the time they just need a picture. Even with fancy video, it's still not as useful as a close-up, good, solid picture or two or three of an area and object, because they can put on their computer, they can zoom up really close, talk it through, they can have meetings and talk about it. The other technology is great, but if you could just get in and get some good, solid pictures, that seems to help them the most for now.
Absolutely. Well, good stuff. Other questions or comments? Does LiDAR have the potential to determine slope, taper to structural and commercial or flat roof systems?
I believe it does.
Yeah. If you can
Yeah,
get it,
because
yeah, I think it can.
you look on some of the scans that they've done with, I've seen work in Egypt, and then Central America. Yeah, they're basically plotting out the whole mountainside, and that's how they find the buildings. They find these rectangles all over the place that are buried under a bunch of jungle vegetation. But yeah, you can get the slope. Even with the mid-level $1,500 drones, the software is there where you can check the volume of piles of sand or rock or hillside.
Thank you for joining us for today's session of Ask the FM Doctor. Be sure to mark your calendars now and join our next webinar at 12 p.m. Central Time on the third Tuesday of the month. We look forward to seeing you again.